In this video, I'm going to solve some problems based on the U substitution and integration by parts. Let's start by the U substitution. The first question is given as follows. A. The integral of 2x times square root of x squared plus 1 dx. Okay, so when we see this kind of integration, always we have to start by letting the u. So there is no good reason to say which one is u, but always try to choose your u, the one something inside the parenthesis, inside the square root, or something that's difficult to solve. So in this case, the most likely I have to say u is equal to the x squared plus 1. Okay, if I decide my u, again I don't have to forget to find the derivative of u. The derivative of u is 2x, and don't forget to add the dx. Okay, 2x dx. Always don't forget to add dx, because we are derivating the u with respect x. If u is x squared plus 1, the derivative of u is 2x dx. And then from this I can solve dx also. Dx is equal to du over 2x. Okay, so these are the very important components that helps me to proceed to the next step. Okay, now I'm just keep going and then substituting all these given values into the original equation. Okay, the integral of 2x, now the square root of u, because I already let the one inside the square root as my u, and then the dx here is gonna be du by 2x. Okay, if I substitute this becomes so easy or handy to do some cancellation. Okay, so I can cancel these 2x from the bottom and then this x from this. Okay, so if I cancel the 2x from both, from the top and from the numerator and denominator, I will have this, the integration of u du. All right, the integration of u du. So that means the integral of u, square root of u with respect u. So this will be, again, I can rewrite this in different form. So that is the integral of u the power of 1 over 2 du, because square root of u means just the power of 1 over 2. So I can apply now the rule of integral. The rule of integral tells me that if I have x to the power of n, the integral of x to the power of n is simply x to the power of n plus 1 over n plus 1. Okay, I have to add 1 to the exponent, to the existing exponent, and then whatever I get, have to divide by that exponent. So in this case, if I add 1 to the power of 1 over 2, this will give me u the power of 1 plus 1 over 2 plus 1 is 3 over 2. Okay, 3 over 2, and then divide by 3 over 2, right? Divide by 3 over 2. Now this means that, again, the next step is I can unwrap my u, because if you remember at the beginning, my u was x squared plus 1, x squared plus 1. So what I'm gonna do is I'm gonna go ahead and then substitute my u. Okay, substitute my u. So that means that here we go, this is u is equal to x squared, right, plus 1 the power of 3 over 2 times 2 over 3. I have to reciprocate the denominator. So finally, plus c, in fact, plus the constant. So this will give me again, or I can rearrange this one. This is 2 over 3 times x squared plus 1 the power of 3 over 2 plus c will be my last answer. Okay, will be my last answer. Let's proceed to the next question. Okay, So simply what you have to do is be careful about choosing your u, and again after you choose your u, make sure don't forget the dx. Okay, many students forget this with respect to x, so that in the next step you can solve for dx and then you can substitute your integral clearly. Okay, clearly. All right, so let's go to the next one. All right, the next one. All right, the next problem is as follows. Let's clean this one and rewrite it again. Okay, let's rewrite this one again. All right, this is it. So what is the integral of okay, let's call it b, the integral of tan x. Okay, the integral of tangent of x. Okay, the integral of tangent of x. So the same thing. Okay, the same thing, we will apply use substitution, but one thing we have to recall from here. Okay, recall. All right, recall what is tan x from the trig relation. Tan x is simply tangent of x is equal to sine x over cosine x, sine x over cosine of x. Okay, sine x over cosine of x. Now I can rewrite the tan x in terms of sine x over cosine of x. So my second step is going to be like this: sine x over cosine of x. Okay, cosine of x dx. Okay, in fact there was dx here at the beginning. All right, sine x over cos x dx. All right, now the next step is going to be now choosing my u. Okay, choosing my u. So you have to be careful when you choose your u. Okay, my u is going to be now cos x. Okay, my u is going to be cos x. Okay, my u is con x. Why I'm choosing cos x? Because I know the derivative of cos x is minus sine x, and then when I solve the dx, okay, when I solve dx, it will bring my sine x in the denominator, and then that way I can cancel the 1 in the integral, the sine x in the numerator with the denominator. What does this mean? All right, so if u is cos x, and then the derivative of u is going to be minus of sine x dx. Okay, so what is dx now? What is dx? Dx is equal to minus sine x, sorry, this is dx is going to be du over minus sine x, and let me rearrange this one. If I divide both sides by minus sine x, dx is going to give me the following. Okay, the following. So dx is du. All right, dx is, sorry about the pencil, this is du over sine x, which is negative. Okay, which is negative. All right, now as usual I have everything here to substitute my integral, so my next step is gonna be this: the integral of what? Integral of sine x over cos x, right? And then dx is minus du over sine x. Okay, the original one, sine x over cosine of x, and instead of this du I'm gonna substitute, instead of this dx I'm gonna substitute times negative of du over sine of x. Okay, so after I substitute this, I can see that two things can be cancelled. Okay, the sine x from this, I can cancel sine x from this. So the next step is gonna be what? Well, I see the negative sign inside the integrand, so I can have that outside. Okay, I can have that outside, minus of, okay, 1 over cos x times du. Okay, 1 over cos x du. All right, so I remember also now what is the well, my u is now cos x, right? From the beginning my u is cos x. I can rewrite this one in this form. Okay, I can rewrite this one in this form: negative of, right, negative of 1 over u du. Okay, 1 over u du. And again, but but the integral of 1 over x dx is ln of x. I hope you remember this one from your previous discussion. Okay, so if that is the case, my answer is going to be now this one. So negative of, that is negative of 1 over u means now the integral of 1 over u is ln of u plus constant. Okay, ln u plus constant. So what is u? U is cos x. So this is going to give me now negative of ln of absolute value u, which is cos x, right? Cos x plus c, right? Plus c. Now remember, this is negative in front. I can go further and then rewrite it in different way. Since I have negative at the front, that means there is a negative number, which is negative 1, obviously, right? Which is negative 1. At the front side, there is a negative 1. So what I can do is now like this. I can bring the negative 1 as a power if I use the power rule of logarithm. That will give me like this, okay? ln of the absolute value of cos x inverse, okay? I can get that negative, this negative, okay, this negative, you can take it to the exponent, okay, to the exponent, still plus c, okay? This is plus c. Again, if I rewrite this one, I can further rewrite this one like this again. What is cos inverse? Cos inverse means 1 over cos, right? 1 over cos. So that means now I will have at final ln of the absolute value of 1 over cos x plus c, okay? Cos x plus c. So this will be my final answer for this question, the integral of tan x, okay? The integral of tan x. All right, let's continue again. The next example or the next problem is going to be this one. All right, number 3, right? Number 3. Let me scroll this up a little bit. All right, so let's delete this. Okay, you can if you want, you can pause and see it again, but hopefully you understand this one easier because they are very straightforward problems. Okay, number 3. So number 3 is this one. Okay, number 3 is this one. Let's see the integral of x times cosine of 2x squared dx. Okay, cosine of x squared to x squared dx. Right. Now, as always, we have to say let u. Right. What is my u? My u is the one inside the parenthesis. Right. Inside the parenthesis, which is 2x squared. Right. Always remember, when we choose our u, it should be something inside the parenthesis or something in a square root or something a little bit weird kind of number or number and variable, something like that. So most likely, okay, about 95% of the time. All right. So if we know this one, what is the derivative of this? The derivative of this is du is equal to, again, you have to remember what is derivative. This is, we bring the 2 in the front and then we subtract 1 from the exponent. So 2 times 2 is going to be 4x. 2 minus 1 is just 1. So this is going to be 4x simply dx. Okay. Don't forget dx again and again. Now let me solve dx. Okay. My dx is equal to, now divide both sides by 4x by 4x. It is going to be du over 4x, right? Now I have everything. Okay. Make sure you have everything before you do the next step. So this is like this. I can rewrite this one, the original equation, based on this u substitution. So that's gonna be, all right, x into, all right, cos of 2x squared is u. Just I plug in u, and then dx is already du over 4x, du over 4x. Okay, now observe, I can cancel something inside here, right? Because I have x in the numerator here and I have another x in the denominator here. Both of them can go. So that means I have now 1 over 4. So that 1 over 4 can go to the front of the integral. 1 over 4, because that's a constant, I can pull it out. So 1 over 4 cosine of u, okay? 1 over 4 cosine of u du, right? Cosine of u du. All right. So what is the integral of cos u? All right. What is the integral of cos u? Remember, the integral of cos u is sine u. So that's going to be 1 over 4. This is equal to 1 over 4 sine of u plus a constant. Okay. Sine of u plus a constant. This can be further written as follows. Okay. 1 over 4 sine of, what is u now? Unwrap u, because our u is 2x squared at the beginning. So plug in that one. 2x squared plus c. So this is going to be my final answer. Okay, this is my final answer. This is my final answer. For x, cos 2x squared is going to be 1 over 4 sine 2x squared plus the constant c. Okay. All right. So let's do the next problem. The next problem is going to be about integration by parts. So just, I don't want to record long video and then I'll just give you another video on the integration by parts. I hope you understand what is u substitution by now, and then it helps us to study.